And I just want to remind everybody, if you want to pull up the transcripts for these videos, which is pretty much the same thing as the captions, you can click on this accessibility button. It'll pull up a transcript for the video so that you can read through everything that they said. So moving on, types of EC2 instances. So just like they mentioned, right? Just like at a coffee shop, you have different types of employees that specialize in different types of tasks. At the coffee shop, right, we have our cashier, we have the latte artist. Funny example, right? Funny analogy, but I suppose it works. So yeah, just like we have different types of workers at the coffee shop, we have different types of EC2 instances that can perform different types of jobs. They specialize in different tasks. So we have our general purpose, compute optimized, memory optimized, storage optimized, and accelerated computing. So these are, you can already see related, right, to the types of computing resources that AWS can sell us. So let's start with general purpose EC2. So general purpose instances, they provide kind of a balance between all of the computing resources. So memory, computation, networking, could be storage as well. So this is useful for all kinds of things, databases, specifically small to medium, because once you start to get to the larger ones, then you're going to need some memory optimized instances. So development and test environments, backend servers, web servers. So pretty much all kinds of applications. It's a balanced instance between the three resources, so you can use it for a lot of different things. So it doesn't optimize any specific resource. So if your app doesn't require like a little extra compute, a little extra memory, or a little extra networking capabilities, then you're probably going to go with general purpose. Compute optimized, that's ideal for compute bound applications, or basically you're doing a lot of processing, tons of data. So think of like your CPU, right? Is this something that the CPU would, go crazy for? So use cases include scientific modeling. So scientific modeling such as like weather data, right? The stuff that helps us predict, right? How hot it's going to be tomorrow. That they're running through massive amounts of data. So compute optimized is definitely going to be good for that. Batch processing. So again, batch means you're handling lots of data. Gaming servers, high performance web servers. So if you need a little bit extra computation, you're going to go for compute optimized. So that's when you need a lot of compute resources. You're processing a lot of data. Now, what if you need to deliver fast performance, right? So again, like your databases maybe are getting bigger, right? But you still want to do, data and analytics, discover trends, amongst millions of records. And you want to do that quickly. You're going to want to have a memory optimized EC2. So this is designed to deliver fast performance for workloads that process large data sets in memory. So some of the use cases are going to be anything that you want to do very quickly. Because remember, memory is all about short term. It's about processing things very quickly. It's kind of tied to compute optimized, right? But one of the big differences is speed here. Compute is more about volume. All right, so in-memory databases, real-time big data analytics. So those are your big databases. High-performance caching. So you're going to want to use a memory optimized instance if your application requires large amounts of data to be preloaded, is one of those keys. Remember, memory is a fast access temporary storage area that loads data into the CPU. So again, while connected to the CPU, this is more about speed and access. This should say accelerated computing. Let me go ahead and fix that now. So accelerated computing instances, use hardware accelerators or coprocessors to perform some functions more efficiently. So this is for when you want a lot of data processing, but you also want speed. This is where accelerated kind of comes in. It's going to use some techniques in like parallel processing in order to process things even more quickly than compute optimized. So where would you use this for? Well, you probably use this in machine learning, video rendering, and graphics. Accelerated computing instances are ideal for workloads such as graphics applications, game streaming. So that's massive amounts of data and you want speed. So an example of a hardware accelerator, something that helps accelerate processing, a specialized accelerator or processor, I should say, is a GPU, right? That's for those of you who are into gaming, right? You're familiar with your GPU. So storage computing, EC2. So storage optimized instances are designed for workloads that require high sequential read and write access to large data sets on local storage. So when it's all about storing data, long-term storage, right? You're going to want to go with storage optimized. So this is a little bit easier to wrap your head around. Data warehousing, distributed file system. So you're just storing a bunch of files. Another one that you might not know about is high frequency online transaction processing. So this is when you need to handle massive amounts of transaction data, store it. You might use storage optimized instances. So this is when you're handling lots of data, but you also want to store it for longer periods of time. Different than memory, right, which is short periods of time. So storage optimized instances are designed for high IOPS workloads. High OPS, that's a measure of throughput in data. You can definitely click on that if you want to learn more. So it's delivering low latency performance for applications with intense storage demands. Our next section is going to be EC2 pricing. So how do we actually pay for our compute resources? So here's a video. Go ahead and watch that, and we'll pick up right after the video.